Participants who have joined in, if you have got any queries related to the hackathon, or if you have started building your solution or have already curated your ideas and have certain queries related to SYCL, please feel free to drop in your queries anytime in the Q&A section, and the moderators would be happy to help you and assist you with your queries. So let's begin with the workshop. Good evening and welcome everyone for the second workshop of Intel One API Hackathon, a hackathon which challenges you to build solutions and showcase the power of heterogeneous computing utilizing Intel One API AI analytics toolkits and its libraries, as well as SYCL/DPC++ libraries. So first of all, before all of you, those who have joined in, first of all, welcome to the session. Uh, all those who haven't joined the Discord server yet, please do make sure that you join the Intel Discord community to get regular hackathon updates, as well as live mentorship for your queries would be provided over there. So it's a request from everyone to those who haven't joined, please do join the Discord server. The Discord link is in the chat box right now. Moving forward, in today's workshop, we'll be gaining hands-on experience with parallel programming concepts such as task-based parallelism, data parallelism, and pipeline parallelism. Also, we'll be learning how to optimize SYCL-based simulation implementations using techniques such as memory management, data caching, loop unrolling, and performance profiling. Apart from this, we would explore the classic SYCL synchronization problem of dining philosophers using SYCL, where we will get a hands-on experience with parallelization and process synchronization. So, with this, I'd like to welcome among us the lead who would be taking us through the entire workshop, the hands-on. We have with us Mr. Abhishek Nandi. He's the co-founder of DynoP and an Intel certified trainer with one API SYCL specialization, making him the perfect mentor for this hands-on workshop. So, hello Abhishek, how are you doing?
I'm doing good. Welcome, all of you.
Yeah, Abhishek. So we have with us the entire audience, those who are interested in SYCL problem statement and working on it. So they would be presenting, understanding how you take them through the entire SYCL workshop. So over to you, Abhishek.
Kaushik, am I audible?
Yes, yes, Abhishek, you are
Okay.
completely out.
Okay. Welcome, all. So, to get started with, let's create a magic because this particular hackathon that we are doing right now is specifically meant for creating something new with SYCL. And as you know, that the high performance computing is evolving with time, we have to take care, like, to move to different type of genres and different kind of computing experience. And this would be fun. And first of all, I would like to call that you don't have to have any knowledge on SYCL. We'll have the journey together and we'll learn through. So I will be a bit slower to start with, but at the end of the day, when you go off from here, you would have something to get started with. Okay. So that's the complete perspective. We'll start the session now. So welcome again. Let's enjoy the ride. Okay. So this is the particular page where you have the information on one API hackathon. I would suggest that if everybody has registered or some new people might have joined it, they can definitely join into this hackathon page and they can get started with the project. So entirely on this particular problem statements, we have three problem statements, but our focus today would be on the medical image processing because for the SYCL, we are using different kind of libraries that gives us better results. As you know that SYCL is an abstraction over C++, and C++ is a very fast language, and your results and your output for the different kind of computing devices we get a very good results for that. So that's our motto for the problem statement. We will be targeting the second statement as of now. And these are the phases. As you know, already I've discussed in the three last hackathon session itself. We have three phases, phases 1, 2, and 3. Let Ping pour in your ideas in the phase 1 and may the best idea win. So let's continue further. Now, deliverables. As we have already discussed for the deliverable itself, participants must be strictly. So let me just give a perspective of what we are expecting. We are targeting working professionals who are into the software field, and we some of the researchers like MTech people who want to be a part of this journey and also learn SYCL, because ideas nurture from research. So as we have more researchers, uh, am I audible?
Yes, Abhishek, go
Yes,
ahead.
Abhishek.
Yeah.
Yeah, you are completely on.
Okay. So the first of all, what we are bringing in the first phase is the ideations that are coming in. Pour in your imagination, what you can create and what you have to think of, because there might be 7 or 8 things you might be preparing for the entire hackathon, but one or two might be the output that is coming in. That's good enough. But the wholeheartedly, what you want to do is like put in your efforts to make the submissions ready and get started. So particularly what you would be given is a GitHub repository where you will be putting up your project. We'll also show how simple things can lead you to score more on the SYCL problem statement. So that would be also prime agenda when we follow along. And also the things that I share over here in this particular hackathon preparation itself would be very easy for you to adapt and also to get acquainted with SYCL itself. Now, similarly for the prototype development also, we have a prototype submission that is made on GitHub. The entire code base needs to be present on Team's GitHub repository. There would be a team lead who would be taking care of the entire process. You can, among your team, if you're single or you have a team, you can work around and have one member who does the entire thing. Work your idea, then jot it down. If you have pen and paper handy, it has been very helpful for me for the last 12 years that if I have something on pen and paper ready first to get started with, the journey becomes much more easier. So that's a prime perspective. And after that, we have the prototype submission, we have pull request, and that's the way we get started. Okay. Now, according to the deliverables, you have started working on something. Say SYCL is very new to you. If you find something amazing, uh, try sharing it with all the tags that are available here with uh, tag Kavita and also the Intel software tag that's there. And you can go back to the previous challenge itself. We had very good experience of using one API libraries. You can take help from that, build upon your journey, and after that we have top 5 winners with highest likes will get an Intel hoodie back during the finale. So that's the way we get started. So start noting down what you're doing, prepare the concept, build it up, and have it compiled and make a big good storyline. So after that, what happens is that it gets printed over. There are so many experience to share, and also you get famous. So that's the way you got started itself. So that's the perspective of deliverables. Now we move on to the timelines. So registrations have started. You have the idea phase open. The current deadline that we see is the registration closes on 30th April. So have your ideas putting in by that time. And we have the phases after that along. So when you're working on a particular hackathon, like I used to do 6, 7 years ago, I used to have some timelines by when we can complete those tasks. So you can take the timelines and you can adjust accordingly and develop your product. Okay. So I would request Kaushik to play the video. So this particular video that we would be seeing right now would be on one API and how to get started with it.
Hello all. In this video, we'll see how to activate a particular environment for the One API AI Analytics Toolkit. We'll see how it works. First, we need to open up this particular window. That's a Jupyter Notebook that we have opened. And when we select this plus button, this there will have this terminal option. You just need to click on this. It will take us to the screen. Now, some steps are needed to be followed. So what we will do is we will have to install a particular version of one API, and there is certain information that needs to be done. So first of all, we'll create this directory ML1 API. I'll go back over here, just create it. The first step is creating the directory. That's being done. Now the next step is getting inside the directory. That we'll do. Here we get inside the directory. Now inside this, what we need to do is we have to use a particular shell script so that it enables us all the factors or the variables that are needed to activate the one API based kernel. So we'll do that. Just wait for it. So it will say that particularly all the environments using like DNN or others are being initialized. Now we go back over here and we'll just use this conda activate base. Now we'll click on this. So the base is being activated. Now after that I will use this. Why we are using this IPy kernel is that it creates an additional kernel that can be added or used for our Jupyter notebook usage. So this is a very particular step, and you have to be clear on this. If you don't do this, your kernel will not appear and you won't be able to use these different libraries that are enabled over here. I'll just click on it. As PyKernel is not installed, it will take some time. So it's looking for all the libraries. Now it's being installed. Now the next step is I will use this particular command. What it does is that for the latest version of one API, that's the 3.1, it shows this particular version and also enables it using 20. And also we are enabling the IPy kernel for the usage. Okay, so if we just hit this, it will take some time. As you can see, the kernel has been installed. So let us see that if that additional factor is being added to us or not. You see, as we have installed the new kernel version uh, in the notebook, in the Jupyter notebook, you will see this one API 2022.3.1. So it was not there before installing the features. Now it has come, and you can use the new libraries like 1DNN for your usage. So that's the way you get started. I'll just click on it. Now you can directly use your 1DNN library because it's now updated for the kernel that you have created. Now you can also change the modes. You can just enable. So the modes are there. So you are ready to work with it. So that's the way you get started with other new libraries from uh, Intel. That is the new libraries that I've mentioned. Like if you can go back, you'll see the list of libraries that I have shown. Yeah, it's ready to be used over here. So give me a feedback if you like the video, and we'll continue the voyage. Thank you.
Am I audible?
Yes, Abhishek,
Hello.
you're audible.
Okay, Kaushik. Okay, so the video that you just that was shown before, this was specifically meant for Intel Dev Cloud because you people might be working on the Dev Cloud itself. Now, some new features are rolled in very fast from Intel side. So if you go back to the video, you can take that as an example, get all the things that are required, and you can move along. Because with the course of time, say 1 or 2 months, there might be new developments coming in. So you can take an example, or you can take this particular as thing as starting point, and you can get started. Okay. And also, I would, at the end of the session itself, I will share my YouTube channel links where I would be putting in more videos for the hackathon purpose, and you can take advantage and you can create your own work with that. So moving on, let's start. Now the code samples for one API. Okay. So this particular option that you see, like one API source and one API samples.git, it has got all the examples that I would be showing, and also some new of them, new things that are there. I am sharing it right now. So one API source, this is the link. And let me just give you a brief intro on what are the things that are there itself. For SYCL itself, you need to go into this particular option, direct programming. But if you want to just clone the entire repo, you have the option of getting into the code, copy this particular link that's there. And after that, you have to open up the dev cloud. I've already opened up at my end. This is the DevCloud page that you see when you register, that's shown. And here, this is the plus button. You need to click on the new launcher, and you'll see something called as terminal. So in this terminal, what you need to do is just key in the command that's there. Or what you have to do is just git clone over here. If you type in git clone and the repo that's being shared over that particular uh, slide itself, you need to just copy in, and the entire repository that's there would be copied, and you can start working on it. I'm not copying it because already I have installed it at my end. So that's the way you can get started with unique kind of libraries that are there. So again, I am just going through it. You need to go to this particular link, one API samples. You have the code option. Just copy this. You can save it and go to DevCloud. Here you have the plus option. Just click on it. Click on the new launcher, and again you will have this option for terminal. You just need to select it, and you can copy. So that's the way you get started with your new project also that you're working upon. Probably it might be SYCL or also on API libraries. This is the way you can clone your repo and work on DevCloud. And with this course of action, like when we move along, there is a demo that I would be showing. You will be surprised by what it does to your CPU and how can you take advantage of DevCloud and where DevCloud wins over the CPU or your local computer. Okay. So let's just go back to this particular the GitHub option that I've shared. Now, the most importantly here, you see direct programming. Here lies the entire SYCL concepts that are there. You need to click on it, and it would open up. You see there are options for all of the things that are available, like C++ SYCL, then C++ FPGA. If you just click on C++ SYCL itself, it would take me to this particular page where you have other options like combinational logic. These are examples based on SYCL. You can try out, but most importantly, the places where you can have a winning entry. You have to be present at this Jupyter. So just when you go to this Jupyter migration itself, there are three particular subfolders created over here: CUDA to SYCL migration, one API essentials training, and SYCL performance portability training. These three options can lead you to a winning entry at the final options itself, because we are looking specifically at examples where you can migrate your SYCL code directly into SYCL itself, the CUDA codes that is there. And if you just move along or select or see the this particular option on SYCL, you'll see all of the things that are being done to take the code from SYCL to CUDA to SYCL itself. Okay, so very important. And very important step, if you have pen and paper handy, write it down, because this particular option can lead you to a winning entry itself. Now, apart from that, you have something called this SYCL performance portability. Uh, in the subsequent slides that I would be showing, you would be seeing something called as the analysis of the code. So the entire analysis code that you see is built upon this notebook that's there. You have the math kernel library, basic kernel. You just explore it. You will have lot of things that you can take advantage and you can create your code with. Okay, so these are the things very important. Just go to the one API samples. You have direct programming. Go to the C++ SYCL option. These, and you again go to Jupyter, and after that you have these three options. I would specially recommend CUDA to SYCL training and the SYCL performance portability training itself. Okay, so let's just go back again to the slide itself.
Hi Abhishek, Kazi here.
Yeah,
Hi Abhishek, Kazi here. Can you hear me?
yeah, I can hear you.
Okay, so there is a question from Dibya Shankar. Can we work on ML projects and AI modeling using SYCL or Intel One API?
Yeah, definitely you can take advantage of it. One of the key things like 1DNA libraries that are there, if you go to the example, let me just go back again to the examples itself. So one API samples we have, here you have the direct programming options, but apart from that, you have this AI and analytics tab. This is a library where you have all the examples that are given from Intel to get started with. Okay, so you can take advantage of some of the features of SYCL and do your machine learning stuff. But for the one API libraries, like if you're working on scikit-learn, you are working on Intel optimized PyTorch, I would specifically use Python as my weapon of choice for the development itself. So that's it. But if you're working on something that's related to core performance, and also you want to change your code from one platform to other, SYCL would be the choice. Because the second problem that you're working upon, the medical imaging problem statement, you can take advantage of CSVs that are there and you can build on the solution itself. So any more questions? We can stop and we can take it.
Oh, there is another question I think that has been addressed, like how images can be loaded.
Okay, so images, what you can do, I will just show it when we get started with the coding itself, like on the Visual Studio. What are the ways you can uh, think of loading the images? Because this particular challenge that we are doing, this hackathon, many concepts are very new to us. Actually, for me itself, it was like spending hours and hours to get all the things ready. So when you work on a journey and when you try to find out the solution itself, there are a lot of hurdles that comes on your way. If you solve them, I think, and I suggest that when you do that, you will have a lot of fun on it, because this is the journey of hackathon. You do something new, and that's the way we get forward.
Awesome, great. We are good to go, Abhishek.
Thank you. Okay, so we have touched upon the code samples for one API that we have done. Now let's start with the poll questions. So time for polling. It's the poll question 1. So over to Kaushik, if you can just start with the questions around.
Yeah, Vishek, the poll is live. So, requesting all the participants to kindly interact with the poll and let us know, like, have you registered in one API hackathon or not?
Okay, so the poll time is over. I have the results at my end, and I see like most of you have not registered for the DevCloud. And again, so at the starting point, as because we are doing the hackathon for the purpose of using DevCloud and also using it in Visual Studio, I would definitely tell you like get yourself registered. Okay, so that's the step one for the hackathon itself. So all of you enthusiasts, like go back, uh, get yourself rolling into the dev cloud, and let's start. Let's start the journey. Okay, so let's continue with the session itself, like where we left off, and let's see what other things we can do right now. Okay, so we are done with the poll questions. Poll question one. Let's move along. So here is the topic today: solving operating system concepts with SYCL. So what we are trying to achieve over here, say the general concept, like computer science enthusiasts, third year specifically, who are into the third year of the engineering, and also MTech students who are researching on system parallelism, will find this topic very interesting, because there are different problems that you can tackle with SYCL itself. Because SYCL, as you can say, it is specifically meant for parallelism. I have chosen this particular concept itself because it adds different kind of information into the code that you're building. Okay, so let's just move along. So the agenda for the day, we are what we would start with is overview of how SYCL can be implemented in parallelism. How to get started with SYCL in Visual Studio, important. This particular point that you see, the second point, is very important because it will help you to build a solution from scratch. We would start the solution building process from scratch. We'll run it on CPU as well as GPU. We'll take the code, we'll offload the code for analysis. Then we'll move along to the dining philosopher's problem. Then we have producer consumer problem itself. And again, moving on, the most importantly, the tips and tricks for getting efficient with SYCL and the new ICX standards, and cool tips for the hackathon itself. So end of the day, I would be sharing one text file that contains some particular usages of SYCL that I've created yesterday itself. That would make your hackathon journey very much easier. Okay, so let's move on. So let's start. So now I would open up Visual Studio. So when you have the open one API based toolkit installed uh, on your Windows system, you will have all the tools necessary to get started with your work. Okay. So here I have the Visual Studio coming up. This is how the entire IDE looks like. You will have all the information at the top. If you just settle in on the right hand side, you will have all the tabs that are necessary for us to do offloading process. Very useful for the coding that you get started with. And when you start your project itself at first go, you will see many more informations that are there. So there is this extension at the top. Here is the most important part of your coding to get started with SYCL. If you are starting with zero also, this is the process you start. You'll just click on this extension option. So as soon as you install the One API based toolkit, this extension will be added to the Visual Studio add-on at the top, and you will see this particular tab coming in. So when you hit this Intel option, you'll have a particular page for opening up the Intel One API project. Okay, I'll just click on this, click create new Intel One API project. If I just click, just wait for it. You have the console, you have other options to start with, because this console app that you see is particularly used for the C++, and for the DPC++ console application, you need to select the DPC++ console tab that's there. You just click on it, click on next, and you can locate and you can save the file that is needed, the examples that you can run on. And then again, to click on create option, create here. So if I just click on create, just wait, what's happening over here? It would create a simple hello world application for you. That's there. It is doing a vector addition for us over here. And let's just go through the code itself. So whenever you get started with the SYCL itself, this is the first thing that you notice, that you are getting started with all of the codes that's available and the page that you start with. Okay. So some of the important parts of the code that I would like to show is this header files. This SYCL header files, when it is being added, you are able to bring in all the SYCL related stuff or the work that you want to do. Okay. IO stream is already there in C++. And if you want to run the application of FPGA or FPGA emulator, that is also present. Okay. And the first line here, when we using namespace SYCL, this is like an object being created, an object hierarchy. Within that, you will have all the naming methods that is there. Okay. So after that, if you want to have a exception handler for catching the exception, SYCL exception, this is the way it's get created for you automatically. You don't have to do anything for it to change it. Now, here you see like it is doing a parallel addition of vectors. You have two buffers. Okay. So most importantly, when you start with SYCL itself, you need to create a queue. Here you see a queue is being created to get started with parallelism process for the SYCL language itself. And after that, within the queue, we initiate buffers. Buffer stores the address value of what you are giving into the system itself. Okay. Now, after the buffer is being created, you will have to submit the buffer with the help of an accessor. Accessor allows us to access what is there in the buffer itself and to read the content of it. There's the vectors, that's the value that you are giving into the vectors. It takes it, and after that, you use the parallel for computing the output itself. And after that, the entire vector addition that you're doing will take time for completion, and you need to wait q.wait. This particular command that you see, or the program's line that's being initiated over here, it allows us the entire application to run, and after that it gets out of the system itself. Wait until the GPU has done the process itself over here. And if you just move along here, in the else factor over here, you can see like it is showing us the default selector for us, but we can change it. If you want to run the application on GPU, you have to select this option as GPU selector. Okay. So this, if there is a system GPU being present at your end, at your local system itself, it will run the process and it would show us the result over there. So let's see if the code works or not. We have changed the default selector to GPU. Purposely, the result of the entire program should run on GPU. Let's go and see if it is working. To run the application, there is this green tab where it says like local Windows debugger, and if you just click on it, the program will start compiling. It will take some time. So the build process has started. You see it has initiated a vector size of 10,000, and on the GPU itself, the program has been run. Okay, so we have run the application on GPU itself. Now, let's see if we are able to run the application on CPU or not. Okay, so one particular change in your code has run the application on GPU. So if you want to run the application on CPU, you have to change this parameter selected as CPU selector, and a name of the selector that you have given, you can change it accordingly, and you are good to go. Now, if I just click on local Windows debugger again, it would open up the application, run it. Just focus on the top. What's the device it's being running on? It's running on a device 11th Gen Intel Core i7 processor, and that's the output. Okay, so we have dissected the first Hello World code that's been given to us, and we have run the application on Visual Studio. Okay, so again, I will pause for a while, and if there are questions, we can take it on.
Yeah, Vishek, there are quite a few questions. I'll summarize some of the questions which are common. Uh, so, can you talk about the differences between task-based parallelism, data parallelism, and pipeline parallelism? And how do you decide which approach to be used for a given problem?
So task-based parallelism is like if you have threads, if you have multiple threads that needs to be added to your application, you can take advantage of the task-based parallelism. Database parallelism means in buffers, if you there is an example that I would be showing later on. In buffers, there are messages. There are multiple messages that you're working on, or if you're working on certain aspects of data that are there, you can definitely use data parallelism for that. So differentiate between task parallelism and data parallelism is that when to choose. Threads are if you have multiple process running, and if you want to release those to avoid deadlocks, you use task parallelism. And apart from that, if you go to the data parallelism, if you have different kind of uh, mm, uh, programming aspects like APIs you're calling, you're working on it, you are trying to mix and match between a large queue, like your SYCL data, you can take advantage of it.
Great. Thanks for answering this question. The next one is how can the process synchronization be used in SYCL to optimize the performance of processing large batches of images?
Okay, so process synchronization that you have already that you can get started with. I will show you one way to do it. Like in your project itself, you are trying to bring in different kind of images. Directly, if you want to work on it, this will not happen. Okay, for that, what you need to do, say, if you have a threading library that you want to use from C++ to SYCL itself, you have to click on the right click on it, and after that you'll have to manage and also add the libraries to it. Okay, so you can add the existing item, like if your header files are placed at any other place, you can just click on this existing item or the new item, and you can bring on those into your system itself. Then with this concept, what you need to do is you have to go back over here and bring in the header files, go through the help libraries that are there in internet to use those libraries and start with it. Again, a very important part or very important thing. This vector size that you see of 10,000, you can increase the vector size, because if you're not increasing the vector size or the size that you're working on the data, it might fail. So you have to increase the data size for your computation, or you can zip the data and you can bring in the data over here to get started. And again, within the queue, you have to initialize certain aspects like the code part that is there. You have to again put inside the buffer and utilize it. So that's like how you do it. So one of the examples that I would be showing later on is like how you get started with different kind of process synchronization. So that might be a very important thing that you can take a look at it. Okay.
Great, yeah. So, as Abhishek said, we would be discussing those concepts and how to integrate with that. So, I think that would solve many of your queries. Apart from that, there is a question like how does SYCL handles memory management, and what are the some techniques for minimizing the memory usage and improving the overall performance of the system?
Okay. So again, so when you're talking about SYCL, you know some of the important operating concept of mutex and semaphores. Mutex and semaphores doesn't work out with SYCL itself. That was the important purpose for this particular hackathon session that we have created, that how do you get started. So if we move along to the next step, you'll see like how we have used producer consumer problem scenario. That's also a process synchronization problem as well as dining philosopher problem. But in terms of using mutex and semaphores, you cannot directly use it in SYCL. So it's a language that's specifically meant for parallelism, and that's the way it's being targeted it for.
Okay, great. I think this sums up multiple questions that we have received, and uh, many of the queries can be handled by following the session for the next part. You can go ahead, Alicia. Yeah.
Okay, thank you. So let's just take advantage of what's there from Intel to more optimize our code or see if there are any issues with it, with some of the options that we can use accordingly. So here you see, like at the top on the right hand side, you have all the magic tools that are needed for you to win this particular solution. Optimize your code, offload it. So I will just click on this. You see, like it says to configure analysis with vTune profiler. So when you install the Intel One API based toolkit, there is something that comes up with you that's known as vTune profiler. You can just click on this, like vTune profiler itself. What it does is that it opens up your window of hope for your entire code that you have written, where it is being offloaded, how do you take advantage of it, everything is being shown over here. So let's just wait for it. Now, if you just click on the performance snapshot itself, you will see the entire space of things that are available for our code to be worked upon. So at the top, we have the performance snapshot or your algorithm that you have developed for SYCL. You can study the hotspots, you can go for the anomaly detection, you can do parallelism and what threads are there in your program, and as well as your HPC performance characterization. That also you can see and you can get started with. Okay, so let's just do one of the possible aspects that we can see. Uh, let's just take an example of hotspots of your program. I'll just click on it. It says like the details that are there itself. Okay. So we have the local host that's being using our application. We have the application that's being working upon. And after that, you have the entire process that's been created. But accordingly, when you install the One API based toolkit itself, there is another supporting tool that's being available for you to do this particular option as a very easy going process itself. Make sure when you are building the project or you are at the final stages of it, make the program run on the release mode, because in the release mode, the entire structure of your file is ready. I'll just do that. I'll just click on it. You'll see the output is being created over here. Okay. So let me just close it. And after that, I will go back to my search, and you will see something called, when you install it for the first time itself, you will see Intel One API command prompt for Visual Studio. Okay. So the base toolkit is installed. Now, if you want to see what's happening around and what you can do with the base toolkit, this is the place where you get started. So I will just open it up on the admin mode. Just click on yes, and you'll see the entire environment being initialized. So here you see all of the libraries or the supportive things that are needed to run the One API toolkit. Everything has been initialized and it is on the latest version itself. Okay. So now if I want to take advantage of these libraries, I have to use some commands. Okay. So this is the GUI or the CLI interface that's there for your One API command prompt, and you can get started with it. So how do you get started? What are the commands that are there? Go back to the One API page. I'll just share it, and you can start working on it. So first of all, I want to analyze the code that I have created. So how we can do? I will type in advisor, then GUI. A particular advisor GUI window will open up. Here you can create your new project. So if you want to create a new project, or you want to see the results of it, you have to go to this particular option that says create project. I'll just click on it. I'll name the project, say as Hack2skill 1, and I'll just keep it aside where it is. But most importantly, to select the solution. Now it will open up the project. Now it says that no application executable is present. That means the project that you're working on doesn't have a particular file to be worked upon. For that, I need to see where I have kept my files that I built in Visual Studio, and I have to select the path for that. So I'll just go over here. Okay. Let me just go back because it's not allowing me to modify. Working directory, it's not allowing me. So I'll just get started with it, no problem. I'll go to this Hack2skill. Already everything is being kept over here. Let me see. This is the application. Okay. I'll select it. I'll create the project. This should allow us with the options. Still not allowing. Okay. So I'll just start with another already created project. There might be some issues with it. Let me just open up already a recent project that I have done. I will show the results of it. Just wait for it to populate. So you have the entire project related scenario that's being created. So when you run the entire offloading process itself, you will see the places where you can improve upon. So it says like if your particular code can be offloaded to GPU with 2 loops that's being mentioned. The particular system speed can be increased to 21%, and also this can be also increased by 1.4% itself. So here you see when you offloaded the entire code at a particular place, or you have offloaded the entire application that you built upon, uh, the places or the stuff that is being created for compute, LA cache, everything is there. But here, one important part for this code is that your 69% of the code that's been created by your end is not offloaded. So you can offload more of the options over here itself. Okay. So to run the offloading process or any other application that you want to work upon, you have to select all the analysis workflow that's being there. If you just select this CPU memory roofline process itself, you will see the targets where you can improve upon. Like there are areas of code that you can work on, and also you can build accordingly. So these are the things that you can take advantage of, and it's freely available, and you can start working on it. Okay. If there are questions, you can take it right now.
One query, Abhishek, it is coming quite regularly. Like, can they use pre-trained models in their projects, or do they have to build everything from scratch?
They can if you are working on a pre-trained model itself, you can bring in the model, but for that you need to have some supportive libraries. Okay. Again, I say that if you want to use OpenCV or different kind of threading libraries for it, you need to select, and you have to install it directly, and then you can work on it. Okay. So it's not like you have everything handy. If you say let's just compare SYCL with Python. Python, what you need to do is just install a pip install library and you are good to go. But for that, as it takes some steps for building up the entire application. Either you have to have build the application using CMake, or you can bring in the libraries that I've shown, like here itself. If I just close the analysis option over here, and this particular project hierarchy that you see, it would show you where to get your solutions to work upon. So here you need to just click on right click on it and add. If you want to add a separate header that you have written at a place outside your application, you can do that. Just click on this new item and add the header files from here. Okay, so that's the way you get started in SYCL. So just if you're good familiar with one language, transition to another language is also easier. The process might be similar, but the way to do it is you have to find out how you get started with it. Okay. So any more questions?
How does the Intel Advisor analyze my code? There's a question.
So Intel Advisor, what it does is that it's an add-on to the Visual Studio. So as you build the application itself, uh, when you start the process, what it does is that it also starts building your application with the help of the vTune Advisor. Like it would run the entire code, check again and again what is happening with the code, and review with the results and give you the output itself.
So there's a request like, can you show an example of an Intel Advisor used on a multi-threaded program? And how can I analyze it from the performance graph?
So that might be a very big thing. Like it would take some time. Keep an eye on my YouTube channel. I would share you how to do it.
Thanks, Abhishek. We can go ahead.
Okay, thank you. So let's just move back to the slide itself. Okay, so we have seen a code and how to get started with Visual Studio with the code itself. When we have analyzed or dissected the code, how to run it in CPU and a GPU itself. Okay, so we have seen a hello world example with the help of CPU and GPU, and also the method offloading process. Now, again, it's the poll time. So can we pop in the second question?
Yeah, basically, it's there. The second question is out there.
Okay.
Participants kindly make sure to interact with the poll, stating will you be proceeding ahead and making the submissions for the sickle problem statement. Do interact with the poll.
Okay, it's time for the results itself. As I see over here, many of you have not answered the poll, right? If we are moving along and if you are talking with different kind of application and we are working together, the best way is to interact. So if you are answering that, it helps me also to curate the content later on itself. So I see like many of you are not decided or we have not answered. Probably I would request you to again um, see like how do you get started with SYCL, and this particular video is also recorded. You can go back and work upon. So let's just move along. So we have the results for the poll question, and yeah, there might be some issues coming in because some other people are telling that they don't have a button. Okay, so let's move on. So now you can see like if you're working on the code itself, there are 4 ways to tackle your problem. So the advisor allows you to tackle the problem in 5 different phases: vector optimization, thread prototyping, uh, heterogeneous building, heterogeneous applications, algorithms, offloading, and also roofline analysis. Okay. So with the help of Intel Advisor that I've already shown, we can analyze our code and present us with a dependency flow graph itself. So when you open up the code, that performance analysis option that you see, where you can do different kind of builds for your uh, application you're creating, it helps us to see like where are the places where you can work on the code, and also you can uh, make changes to it. It can help you best candidate for the parallelism itself. So now you can see like in terms of your code that you see uh, here. First of all, on the x-axis, you see you have the arithmetic intensity, and on the y-axis, it's the flops per second. Okay, so your code that you're building upon, that doesn't change on the x-axis, but in terms of the y-axis, you see it shows like it might be running faster or it might be running slower itself. Now, here is the CPU option. Like you have a maximum limit for the CPU that you can work upon. That red line shows us the line, place where to the maximum point where the CPU can work, or your hardware has the limitations that you see. Okay, so roofline analysis helps us to show us what are the things that can be done with the code itself. Now, at times you see the problem is not only with the computer memory bandwidth, but also it can halt the system itself. So mixing, matching together both of the things, we get something called roofline analysis. A roofline analysis helps us to see which of the code or the code places where you can work on your optimization and get a good result itself. Okay. So if you see a red option being created at your code, you can take that advantage to work on that part of the code itself. You don't have to go work on other parts of the code that is there. Uh, any questions? Okay, so let's just move along. Okay, so good to get the Intel Advisor right now, and you can install it from this particular option, or you can have it as a one API based toolkit uh, added also. Okay.
Hello, Abhishek. Just a point.
Mhm.
Can you talk a bit louder so that many of the guys are saying voice is not clear? So yeah.
Okay. Am I audible right now?
Yeah, you are. Perfect.
Okay. 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 So moving along, what we will do is like we'll go back to DevCloud, because we were spending more time on the Visual Studio IDE that's been given to us. But let's see what are the things you can do with the DevCloud itself. Okay. So if you go to DevCloud, here it has been opened at our end. And if you clone that particular library, that is the one API samples that's been given to you, you can start working on the application itself. Now, let me just show you where I have all the uh, applications ready right now. So to get started with, there are a couple of things that are indeed important for you to build up the application. There is this qsub file that contains all the information of how do you put the particular files that you have created for the IPython notebook to the server, and it does the work for us, and a shell file, that is this particular shell file. If you see a simple 1.sh file or simple 2.sh file, it contains all the information. Now, if I open up this file that is run simple 02.h sh itself, and if you go back to the the GitHub window itself, like the one API samples places, you'll see here at one API samples going back to direct programming. When you clone it, I'm showing the place where you have all of these located. C++ local, go to Jupyter, and SYCL performance portability training. You'll see a lab folder being created where you'll see all of your C++ file or the SYCL files that's there. And after that, to get started with, you, as I mentioned, this Q file, if you just open it up, you'll see what exactly it does. It selects for all of the GPUs that are available on DevCloud, and you can select from one of those and you can build the application. So if you want, if something comes up new, just focus on this part of the code where you have to change this else parameter so that you can add additional GPUs that are available. Okay. So that's the way you get started. Everything has been given. You have to alter certain changes on the code and you can make your code much more better. Okay. So one thing is the Q file that I've mentioned, very important. And other one is the shell file that already I've mentioned. Like here is the shell file. This is the run.sh file. It is also similar. One particular option that is very important is when you change this compiling option to ICPX SYCL, that is to the standards of the new standardized SYCL libraries, your code will be compiled with the latest SYCL compiler that is being available from Intel itself. So just focus on certain things. Like if you're working on where the C++ file or the SYCL file lies and where you are working upon. So this particular line, ICPX fsql lab, compiles the SYCL code that's been provided. Okay. So importantly, what I've said, Q file is very important in terms of building your application in DevCloud. Then you have the shell script that submits the job and also the SYCL program that you have written to the server, and then you get the output. So the output that you see, it might look like this. Okay, so it gets submitted to the server, Intel DevCloud server, the CPU that takes advantage of it, and then you get the output itself. So I have a hello world example that I would like to show over here. Okay, so here you can see, like at the top, this 2% criteria that has been shown. This is a magic code that's being written in Jupyter Notebook. So if you search for like magic lines in your code, there are options that you can utilize in Jupyter Notebook. So one of those is this write file lab, then your SYCL code. Okay. So what it does is that when you write this option in the lab folder here, at the left hand side, you see the lab folder. Within that, your hello world CPP or the SYCL code will be written. Okay. So it's being created that way itself. So what you can do is that you can create a new Jupyter notebook. Just click on plus. Then you have the options for opening up a new notebook. Select it and you proceed along. Okay. So this hello world example, what it does, it first creates a SYCL. So anything that you want to work upon on a SYCL itself, you'll have to create a SYCL queue for it. So until and unless a queue is being created, you cannot get inside a particular statement where you can share your messages or say add it to the buffer to get it working. So what example it shows? It says that I've created a SYCL queue first, then I create a buffer. Within the buffer, I have a message as hello world, and after that, I initiate a command group to take this buffer into consideration, and with the help of accessor, I read the statement that's being provided, And finally, with the task parallelism that's being done with a single task itself, I output the result. And after that, I would wait for entire process to get over. And finally, the program is it's itself completed. Now I'll just run the selected cells. Here you see the options for your kernels. You can select the kernels that are there. Already I have this Python 3 kernel at my end. I'll select it and I will run the code. You'll see when I run this particular tab itself, the lab file would be created. Here it says that it's being overwritten and the hello world CPP file has been created at this lab folder. Okay. Now, here lies the option of running the shell script that's been provided. Make sure the GitHub files that I've shared, you will have these shell scripts. You have to pass it along in the same manner that's being provided. These are the options that you are putting into the Linux system. And after that, if I just click on run, what it does is that the job is being systematically provided with the server itself, and it's doing the job for us. So directly, you cannot access the best process that's there in DevCloud. You have to submit your job. Similarly, like it's the concept of supercomputers also, that you have been provided batches. If you are in IITs also, you will see that you are allocated time to do the job. Similarly, for another good option that's there in DevCloud itself, that you can take advantage of these features directly. Okay. So now the file is being submitted, it's running along, and also it shows like how much time it would take for output. But if you're considering it's a big problem or a big solution that you're working on, or in training purpose, don't do it in DevCloud, because training takes time, and at times you will get a timeout error. Okay. So it says that the hello world problem has been successfully submitted and it's being run. If there are errors, you will see the errors popping in at this option. Job completed in 46 seconds. This is an output that's being given directly from the server itself. So you have submitted your job job to a queue, where the queue where the queue that's being available picks up your job. It's puts into the server, and when the job is being submitted, with the help of the shell script and also the other supporting files that are there, it collects the job and gives you back to the output itself. Okay, so that's the way you get started with direct applications that you're working on. But apart from that, this DevCloud is entirely free. Take advantage of it, the plus, because a lot of things that you can explore and you can run upon. And make sure you go back and work on this library. Or if you're working on a SYCL statement, this particular one API samples that you see is very effective, and you can learn a lot from it. Go to the direct programming, and then you have the options over there. So any questions right now? We can just pause and we can take it.
Some queries were coming, like if some examples from Python were given, we'll share those links and some demos, like one API usage with Python-based codes.
One API, yeah, definitely. So keep an eye on the Discord channel. You would be updated with all of the libraries and also the supporting stuff that's being created, because the previous workshop we had was on one API libraries, specifically meant for Python itself. This is targeted towards SYCL. Okay. So
Okay.
any more questions?
This is fine, Abhishek. We can continue.
Okay, thank you. So let's move along with the dining philosopher problem. It's a process synchronization problem that we have in operating system. So dining philosopher problem is a classic example used in computer science to illustrate synchronization issues that can arise in concurrent programming. So when you are talking about concurrent programming, that means like there are multiple processes running together, and how do you solve that? the problem involves, if you just study along in operating system itself, 5 philosophers are there who are seated around a circular table with a bowl of rice in front of each philosopher. There are 5 chopsticks available with 1 chopstick placed between each adjacent pair of philosophers. The goal is to find a solution that allows. So if you're talking in terms of philosopher, it takes turn for the chopstick, and in front of them, they eat while ensuring their 2 philosophers that have around a table are not holding the chopsticks that are needed for other to stop. Okay. So several solutions have been proposed to solve the dining philosophers problem, including using semaphores, monitors, and synchronization primitives, like critical sections that you have. You take advantage of semaphores to solve it. But again, rest assured, like semaphores and other libraries are not supportive and SYCL, we will not use it. Okay. So let's just move along and see the solution for this. And also the applications that we see over here, it's being shared. You can just take the example and you can change and alter the code account. So we'll just see where it is located. I have kept it at open the project. I'll just see where it is. See Hack2skill. Okay. This is the dining philosopher problem. I will just select the solution and click on open. Okay. So couple of things that you see from here is that first we have included the SYCL header at the top. And as we are taking advantage of philosophers, the 5 philosophers that we have seen, we have added it. Most importantly, there are 2 forks that does the job. Like you have one attachment, so we increment it, and with the number of philosophers that are there, with the right fork, we are just utilizing the availability of plates. But what was the other scenario, that we have a waiter who checks for the process synchronization or deadlock doesn't happen. But as we don't have something to store, or this ideas that we have for the entire dining philosopher problem to work along, we are not using that. Okay, so here you see that it's both of the process, like it's trying to with the help of the left fork, it is trying to pick up the fork itself, and with the right fork itself, the function is being stated here, it's also doing the same thing. And with the help of that, this milliseconds, so if we just focus along this milliseconds, if we is the time that is needed for us to avoid the deadlock. And at the bottom itself, on the left fork and the right fork, first we have initialized this to false because nobody is holding the fork right now. And after that, our philosopher thinks for a while. That is also given a time period of milliseconds. And with that, you are able to run the entire process itself. Okay. So these are the looping factors that are being added, like with the size of the number of philosophers that being provided, we increment it and we reference the fork along. Okay. So again, when I was working with this particular problem, what I did was, because it was very unknown for me and it was a very unknown scenario for me, how I solved the problem. First, I found out that if I'm able to use mutex or semaphores or not. So when I get started with solving this problem, mutex and semaphores, we were not able to use at all in SYCL itself. So after that, what we did was I started again experimenting with how can we solve it. So if you go to the SYCL standards, you will see, like in the libraries itself, you'll see a lot of options that are available for us. I started using it is in an experimental basis, and finally came to this particular solution. Okay, so most importantly, you will see I have used the SYCL construct, but the program logic that's been created over here is in the C++, because if I use the buffer and if I don't use particularly the standards of the SYCL itself, it was resulting in deadlock again and again. and my program was crashing. So here comes an opportunity. Within the SYCL construct, you can directly use your C++ codes to work. Okay, so let's see how it works. I will run this. So it iterates through, and the entire process is being run accordingly. After a particular iteration of time, the dining philosopher program exits. Okay, there is no deadlock. But if there was a issue itself, like what I was doing is I was trying to build up the application and my system was crashing. Yesterday itself, it happened that it was so badly affected and it was heating up so rigorously, and there were so many errors. So these might also come to you as the issues that you have when you try to solve problem, but it would be a rewarding experience for you when you get started with it. Okay, so that's the way of getting into the dining philosopher problem. The entire code is being provided. You can see how the things work, and entirely before going into the poll question 3, I would show you one more process that is producer consumer problem. That is also a synchronization problem itself. But on that, I was able to successfully use different SYCL construct itself. I will again go back to the dev cloud. As I would show. Okay. So if you just keep your dev cloud aside for a while, it goes to a sleeping state. Again, you have to restart the server. So when you are using dev cloud again and again, these problems might appear. But again, uh, as you see in this particular seminar itself or the session itself, we are able to get into what are the things that can occur with the dev cloud and how we can restart it so that you are on the same page itself. Now, if I go to the options of the, let me just involve it. Performance portability. I will just open up this SYCL performance portability, and I was working on this particular notebook that says producer consumer IPython node. I'll just open it up. Okay. So the GitHub file that's been shared to you, you will see something called run accelerator.py. You might be asking like what it does, like what exactly is happening. So if I open up this file, accelerator.py file, you'll see that I've initialized a widget where it is taking a radio button. And within that, you have the options for all the GPU that's been available for us. Like if you have new GPUs coming in, you can add in the option, and also you can work with the new GPUs that are given to you. Okay, so in the producer consumer problem, let me see like if I am able to get the widget working or not. I'll just go through it. Just wait for a okay. Let me change it to say one of these producer consumer IPython notebook. I'll just click select. Let me see if this widget is appearing or not. Okay. So you see, like changing the kernels from one particular kernel option to other is allowing me to show what are the radio buttons available and the GPUs. Or if you have any other additional GPUs of itself, you can select it from here. Okay. So these are the neat and the clean programming process that you can take advantage of it, and also the final submission that's been provided that looks good itself. The producer consumer problem. It's also a synchronization problem that we have seen. So the code is simple. Example of the SYCL statement, that SYCL programming standard that we are using. It implements a producer consumer pattern for a processing in the GPU. The producer and the consumer, what exactly is doing? Producer is creating certain stuff and consumer is just consuming what is being produced. To avoid the overwritten process not to be complete, not to interfere between the two, we have to avoid a deadlock for that. So the producer consumer has to work synchronously. So the producer function generates some data and writes it to the buffer, while the consumer function reads the data from the same buffer, processes it, and releases the buffer itself. Okay. So these are like what are the things I've done with the code. And after that, just find the difference in the code itself. Here you see that I have used SYCL standards. I have used a namespace as SYCL, and I put in an iteration standard of 5. And again, I've created a queue. So the changes, you can take example of these particular examples itself for producer consumer and also the running philosophy, and see like how you can uh, have your implementations on different kind of problems that you're working upon. Okay, so for the previous problem statement, I didn't create a queue, and for this I've created a queue, and also after that I have initialized a buffer, and finally the entire iteration for the producer consumer works accordingly. Here also I have selected a GPU selector. That's the GPU that's been provided, and you can run the problem itself. Now, if I just click on run, what it does is that uh, it would override the producer consumer file that's been written. And again, if I run through it, it generally takes time and it shows the output in this manner. Like every iteration that has happened, it would show me the output accordingly. Okay. So that's the way you get started. But apart from that, there are a lot of things that's being provided in the sample from one API itself that you can check. So you have built a code right now. You want to analyze the entire roofline scenario that's been provided. So how do you go about it? There is this math kernel library and basic kernel flow that you can just move along. For that also, you need to select one of the kernels to get started. I'll just select this one API kernel that's being available. But most importantly, if I go to the rock bottom, these are the things you can do with the IPython notebook. I'm not covering entire thing because it would take some time, and it's also there in the example itself. You can just see how the things work. Okay. Now here I want to show one of the options, like the roof lining process, how it works. So if I select this and I click on run itself, just wait for it. Let me change the, okay. So here you can see in the code itself, if I show, like there are process where there are places in the code where you can see like if there are improvements needed or in it or not. So entirely you can check for the best possible uh, flip-flops available for it, and also you can select for the different memory level that you can see that where the code has behaved very well and apply, and you can see the output itself. So just go through the examples that's being provided, and you can see a lot of things appearing, or like here you see a yellow spot, that means this particular portion of code you cannot improve at all. Okay. We have to find areas where we have the uh, red option, because that's the portion of the code that you can alter or you can offload according. Okay. Let's see if there are any in this code option. No, it's not there. So you can just see the examples, and after that, if with the help of YouTube library that's being created, you can take these examples, like how it has worked, how the GPU has done the work for it. When you're building the application, take the snapshot, put it into your hackathon entry, and we would get a very good picture of how the things are working for you. So that when you are coming to the finale itself, we can just have a look at this and we can see where are the portions we can work and find a very good solution at the end. Okay. So to get started, here is the option in the direct programming, C++ SYCL, and you go to the Jupyter option. Again, you have this SYCL portability training. All of the things that I've shown is here. Okay. So it's been provided from Intel itself. You can go back and you can take advantage of. Okay. So any questions right now? Okay. So let me just go back to the slide itself. We have touched upon the dining philosopher problem. Now, again, time for poll question. So over to you, Kaushik.
Yes, Abhishek. And the poll question is live. So, participants, it's a request everyone to kindly interact with the poll. The poll this time is how many of you have used Visual Studio as an ID? So, I hope, like, I'm presuming almost everyone these days is using Visual Studio Code. So, do let us know in the poll section ASAP.
Okay, so it's time for the results itself. Right now, we see like many of you have not decided to answer, but accordingly, I see the majority who have answered, they have used Visual Studio. Okay, so it's we are good to go. Okay, so let's move along. So if we have any questions to move on further, we can take it. Otherwise, I will start. Okay, so there are some issues with poll not appearing. Okay, so let's just move along. So I've already mentioned the producer consumer problem that's being shown. So the producer consumer problem is another classic synchronization problem in computer science. Again, it says like it uses two threads, producers and consumers. Okay, the producer generate data and add item to the shared buffer. Consumer removes them, and that's the way. So we have seen the entire process of producer consumer problem, and we have also solved the problem itself. And these are the resources, but importantly, some you might be asking like how it is different. Like if I'm using if I'm building the application in CPU right now, if I want to see like how the application behaves differently in dev cloud, I will show you how to, what are the things that you can do with the dev cloud itself. Now I'll run an application here in CPU. We'll see like it doesn't work out along uh, as well as it runs in dev cloud itself. So let me just open it up. I believe everybody is able to see the Visual Studio that's being opened. I will just open a project file, open project solution. Then we go to this matrix multiplication option. I will see. Okay. So the matrix multiplication that you see over here, it's an example that I took it from C++ and then I just ported it to SYCL itself. But most importantly, the gist of it is like number chunking. So number chunking in matrix multiplication process is very high. So if you see right now at the top, here you see that the size of the matrix is 8 into 8. Okay. So if I just run this application, just wait for it to come in. It will take some time to do the stuff for us, like the entire programming process that goes along with doing the matrix multiplication with 8 into 8. It's very fast. We are able to do it. But if I change the parameters, say if I put in 128 and 128 over here, you will see again the application takes a lot of time to complete. I'll just start running this again. Okay. So you see, like right now, the performance is slow, and in the system itself, because it's a number crunching game that's happening at the back end, it's taking a lot of time to complete. Okay. But if I do the same application in DevCloud, this would be completed in just a whisker of a time. I will just stop it because it will again hang my system. Okay, I will just stop it. I'll just go back to DevCloud right now. Okay. Here at the bottom, you see this option of matrix multiplication that I've done over there. It used 128 bit matrix, but here you see 1024 into 1024. So you will see like how fast the thing works. I will just run it. Let me just select the kernel. Just run it. Here overwriting the files. Now I'll just submit it for completion. It says the final output has changed. I'll just overwrite it. Just wait for the output. What do you say? Will this result be completed or not completed? It would be completed because it is using a Xeon processor to complete the work, and it's very fast and effective. Just wait for it for the final output. Okay. You see the results have been completed, and it also shows the kernel execution time. The same problem that you see, like if I run it in Visual Studio, I was using only 128 by 128 bit matrix, but here I have used 1024. Okay. So it says like you are using 1024 and you are getting a very good result. So these are the wonderful things that you can do with the DevCloud. Okay. So you might be doing one application that is slow at your PC. Take it to GitHub, and again you run it over here at DevCloud. So these are the things that are very important for your hackathon entry. And if you just move along the things that I've shared or I've showed, it would help you to make a very good compelling storyline itself. Like how do you compare the codes in your DevCloud, and how do you compare it in running it on CPU itself? So both of the things are different, and accordingly you can take advantage of it. Okay, so again I will just open up a notepad and I will have you have things like ready for you. What are the things that are there? So let's see. Importantly, if you are in DevCloud, you have a queue file that is your queue submission file, queue sub file that would be required to submit your job to the queue. You have a star dot shell script that is doing the job for you to be processed along in the server, and you have star dot ipython notebook that is finally pulling up your code and putting it into the DevCloud access itself. And within the lab folder, all of those SYCL files are getting stored as a CPP extension. Okay. So these are the very important things that you would require in terms of pulling up your code in DevCloud. And four things are very important for your code, for your final applications to get submitted and also to be looked upon. And after that, when your code is being completed, what you need to do? Offload the code to advisor. Keep an eye on Discord. We'll be sharing more information on it. And check for areas. Check for areas where the code can be improved. The code can be improved itself. Improved. Do roofline analysis. So this roofline analysis you do might be a very important factor on winning the challenge too, because you will be comparing the results of different prototype runs that you have created in your dev cloud as well as your CPU itself. Okay. Uh, I have one particular file handy with me that I've created yesterday. What exactly it does is that I'll just show it. Okay. So this context.txt file, I will just share it along. It's like what you can say is a cheat code for you for SYCL itself. So the first example you see is the hello world example. Hello world example that we have shown, like how to get started with SYCL. We have created a SYCL queue, and after that in the buffer, we have added in a message over here. Then we have the command group to execute the entire code. Finally, we have handler to run the code, and we move out. But you might be asking, like when I was doing some applications yesterday, that I want to pass in multiple messages along. There only here I am sharing one particular message. But if you want to share multiple messages or multiple data points, how do you get started? So here is an option. Again, the second code that you see, the multiple message option here. I've done is that I've used an array of messages over here where I am passing in multiple messages. Similarly, you can construct an array where you can use different data points, and you can bring along your data points to work together and mingle along and create a final product that you're working upon. And after that, you are also creating a buffer, 2D buffer, that is collecting your points. One of the core things that you see in here is the size of the place where you are storing your result itself. We have used a 1024 byte space for our work, but you can, if you want to use it, or if you can create an n-dimensional buffer, you have to mention accordingly in the output itself. And finally, the message size that is being created and the output is being shown itself. Okay. Now you might be asking, like, I have multiple devices at my end, like CPU, GPU. Is there a chunk of code that I can take advantage of it? Yes. This is the line of code that I've created where you can select for the device itself. You can check in if GPU is available. If it's not, it will just take you off. So this particular code that you see over here is using a device queue, and after that it selects for CPU or GPU it's available or not. And this is the matrix multiplication code that's being shown for a big chunk size, and another is for the small chunk size. So at the end of the day, I would just share it because I've created it today itself, so that it's a very easy access for you to get started. Okay. So these are the things that we have covered in terms of SYCL itself. Let me just go back to the slide if there are things that can be touched. Let me just. Okay. So that's my YouTube channel. You can register in my YouTube channel. I will be sharing more videos on SYCL as well as OneAPI libraries that are there in terms of SYCL and Python both. And you can see the videos and you can create your demos. And apart from that, I post regularly on Medium, and that's my GitHub link where I have the project. Let me just open it up. I'm opening up the GitHub over here. Okay. So if you go to the repositories option, I have created this. This is one of my research work that I'm working on, the molecular dynamics. Apart from that, if you want to work along molecular dynamics in SYCL and offloading, you can check on this. Apart from that, some of the other examples that I've done, like line integrals, predator prey on SYCL, and one API scikit-learn. Some of the people were asking, like, if we can use different kind of libraries, you can take example of this, and you can build. This is particularly used Iris for our work. So that's more of like, what are the things you can do? If you have questions, if there are questions, I'm ready to take.
Thank you, Abhishek, for the session. Participants, if you have any queries related to the hackathon or anything related to the workshop, you have doubts about SYCL, you have doubts about Dev Cloud, or you have doubts about anything related to how to build around the problem statement too, um, Abhishek is here with us. He'd be happy to help you with your queries. So please drop in your chat before we wrap up the session today. Also, we would request everyone post the workshop to kindly fill up the survey form. It is pretty essential for us to be aware of how the session has been, what have you been able to grasp on. So make sure to fill in the survey form as well after the session.
Okay, so I see some of the questions. I will just try to answer those. Like Santosh has asked, like, can we submit a project that we have already started working on before the hackathon? Yes, you can definitely work on a statement that you're already working on, and you can build on top of that. And we have another questions like, can we submit a project that we have already started on? Yeah, that's being handled. Can we use third-party libraries in our project? So if you are talking in terms of third-party libraries, the primary focus of this hackathon is using the one API libraries. Okay. So when we make the final judgment for the entire application, it would be uh, how you have used one API as a prime component on your application. Is it driving the other libraries or not? That would be entirely a scoring area for us. Yes. So in terms of SYCL, as I mentioned, like SYCL is an abstraction in top of C++. So any standard you see is the modern C++ that's happening. And after that, when you are building on top of that, taking advantage of it, the extensions also you see, it's a CPP extension itself. So SYCL is built on top of the C++ and it's been named as SYCL as a language itself. It's a standard that's been coming up for parallelism to get acquainted with. Can we do multiple projects like individual and group project? That that you can check on the criteria for your the problem statement that you are working upon, or you will get the answers in the in Discord itself. Okay, so that would be it. Again, before ending this particular talk on the hackathon itself, I would say that happy coding. The journey would be rewarding. At the end of the day, uh, I will close my talk with this particular proverb from Neil Armstrong, that one small step to moon, a giant leap for mankind. Thank you.
Thank you, Abhishek. Thanks a lot. Before we wrap up, there are a few more questions which we do see, Abhishek. If you could, it would be really great if you could answer those. Like, can we use DevCloud FPGAs with one API? What are all the libraries required? And then there's, can we use pre-trained models in our projects, or do we have to build everything from scratch?
So, can you just have the problems like one by one so that
Yes, yes, yes.
question one, yeah, just
So the first question is, can we use DevCloud FPGAs with one API? What
mm.
are all the libraries required?
Okay. So DevCloud FPGAs you can definitely use. Let me just share my screen once. I will show you how to use it. Uh, if you, as I was showing the one API samples here in the GitHub itself, we'll see another folder being created for FPGA. Let me just go back. Jupyter C direct programming. Okay. So there is something called C++ underscore FPGA folder. Just go inside it, follow along the README. The README that's being provided from Intel is very effective, and you see how to get the entire thing to work along and what are the steps that are needed. You can just go to this getting started option. You have the fast recompile, fast compile, and fast FPGA template. Just see what's there. Inside that, you can run the sample and also follow along. Focus along the README that's being there, and you would be able to run that on FPGA emulator that's being provided from DevCloud itself. Okay. So next question, Kaushik.
Yeah. So the next question is, can we use pre-trained models in our projects, or do we have to build everything from scratch?
No, you can definitely use pre-trained model for your project itself. So if you're using one API libraries, uh, some of the applications that you would be building, you have a concept in mind. Take advantage of those pre-trained models, bring it into modeling profile that you have for Python, and then you can build along.
Yeah. So that was it in terms of the queries, Abhishek. So thank you, thanks a lot for taking us through the entire cycle, how to get started with it, and also basically how to utilize it in our project. So thanks a lot for that workshop, Abhishek. With this, for all the participants who have joined us today, please make sure start making your submissions. You have a clear cut idea. If you haven't joined the Discord server of Intel, please do make sure you do join it. uh, do start utilizing DevCloud for your project. If there are any queries, feel free to reach out to the mentors on the Discord server of Intel itself. Apart from that, make sure that you fill the server link that was circulated in the chat. We'll drop in the survey link once again in the chat box. You will receive the recording of the session tomorrow over mail itself, as well as on your dashboard, so that if at all at any time you require the resources or certain things that were covered in the workshop, you can get back to it on the dashboard and have a look at it. Remember, the idea submissions close on 7th of May, so please start submitting your ideas. The first draft, that would be which you have learned from both the workshop, irrespective of what the problem statement you are selecting. So do make sure that you incorporate Intel One API, AI Analytics Toolkit, and SYCL plus DPC plus libraries. So thank you, everyone. Thanks a lot, and thanks again, Abhishek, for joining in today and helping us out with SYCL. Thank you. Thank you, everyone.
Welcome.